What you need to know before starting Abaqus as a beginner isn't always obvious, and skipping these basics is why so many people get stuck. Watch this video as I show you exactly how to begin the right way. We'll go step by step through the essentials you need to understand before diving into Abaqus, using a simple example to make everything clear. By the end, you'll know how to navigate Abaqus with confidence and avoid common mistakes most beginners make. So let's get started. Okay, we start with standard explicit model. So when we open the Abaqus CAE, we have different parts. For instance, on the left hand side, we have the model tree. Everything we do is recorded here. For instance, if we create a part, it goes under here. If we create a material property, it goes here. We have different things like assembly or steps. And we have the modules here. There's a drop down menu. We have part, we have property, assembly, step, and so on. We get to them later. And here we have some options like file. We can create a new model. We can open the file. We can save it. We can set the work directory. For instance, here, this is very important in order to track our files. We have the views here. We can have different toolbars. Like here, if I uncheck the views, we lose this one. So I want to have this all the time. So we can have views. We can also change the location or the position of them here, holding these dots with left click. And yeah. Alright, the first thing we need to know is how to create the part. So from here we create part, we can write the name for it, we have model space, we have 3D, 2D or axis symmetric. Based on the model, we choose one of them, and each one of them has different types like deformable, discrete rigid, analytical rigid or Eulerian, and we have different shapes for them. For instance, solid, shell, wire or point. Let's say we want to create something very simple like 2D deformable shell, and here we have the approximate size. This is the size of the sketch. As you may know, we don't have any units or any predefined units in Abaqus, and the very first thing we can do is to set the approximate size. If the approximate size is 200 and we click on continue, the sketch is 200 by 200, and if we call that 200 millimeters, everything from now on would be in millimeters. If we want to have centimeter, we could have, for instance, the number of 2. So here we have different ways to create our objects. For instance, we can create lines, we can create points, or we can create a circle. For instance, if we want to create a rectangle, we can left click and we have a rectangle here, and we can add the dimensions to it. So by holding this one, you can add the dimensions. So this is 30. There's no unit for that, but as we meant the 200 to be 200 millimeters, it means this is 30 millimeter. So okay, so we can assign the dimensions, like we can have this one as 40, or we can have different objects here. If I want to create a circle here, I can create a circle in the middle. So when we extrude the part, this would be hollow. We have different options here. I cannot talk about all of them. It's better to get acquainted with them in different examples in future. So we created a simple part and we added a dimension to it. If we want to make this part, we can either click on the scroll button or we can have this one and done. And as you see, we have our model. Simple as that. Again, there are tons of options here on the left hand side. I cannot explain them completely. It's better to learn them through the examples. But here we have create partition. We can, for instance, have the edge or face partition. If we want to add some lines to it, for instance, we can have face and sketch. We can go to the sketch again, creating lines like this and modifying our sketch. So I don't want to do that right now. We can also have use shortest path between 2 points. So we don't have a cell, we cannot use cell, we can only use face and edge. And here we have cutting planes. We can create some cutting planes, or we can sweep and extrude some of the lines. I explained them fully in other examples. Now if you take a look at the model tree, and if you click on this one in this plus here, we have the part one we created. If we open this one, we have features. So we created a shell planner, we created through the sketch, and if we create some sets associated to this part, they would show them here. If we have surfaces, so if we create lines, there would be different surfaces or skins, we would have them here. So this is very important to keep track of the material in here. So if I create some lines, for instance, let's say by face and shortest point between 2 points, shortest path between 2 points, and create a partition like this. So we have this line, and if we go here, we would see this partition face. We can edit that or modify that, or if we don't want them, we can delete this. Okay, now let's go to the materials properties. Now in this module, we can create material properties here. For instance, we name it steel. It's just an example. We can have general density, we can have mechanical elasticity and elastic. So pay attention here, as we don't have any properties at all here and we have to create everything from scratch. It's pretty vital to know the correct units for our materials properties. So if you go to FEA master, and here you can see that there's a unit conversion in one of the posts. I put the link in the description down below. You can see for length we can have in SI millimetric or metric, or we can have inch, and we can have a stress here, we can have Pascal, megapascal for millimetric, stuff like that. So as we need to have megapascal here, this should be 210,000 for the Young's modulus, and the Poisson's ratio can be 0.33, and we can have different densities, stuff like that. 7.8 E-9 would be ton over millimeter cube, so we should input the correct materials properties. As we created the materials properties, we can create a section. So we can create a solid homogeneous section, shell homogeneous. This is kind of tricky here. I create a solid homogeneous, and then I need to assign the section to this one. So yeah, okay, as it turns green, it means the material property is assigned to this section. Again, we have different options here, but we'll just pass. Then in the assembly, we can assemble the model. Here we can have parts or models, but we have only parts here. It can be part dependent or independent. As we have only one part here, I make it independent. And okay, so there are different options here to translate the instance. For instance, if you want to translate it from here to here, you can do it. Then you can reset the view with auto fit here, and this is for translate. Or you can rotate the instance. For instance, you select 1 point here, for example, you say 45 degrees and enter, and as you see, this is translated, this is rotated, and you can press on the cross here to undo that. And there are merge and cut, stuff like that. You'll see them definitely in next videos. So next thing is the step. So in step, we can create a step coming after step initial. I already talked about dynamic explicit or implicit, but most of the time we go for static general. So I can create a step here. The time period is 1, this is relative, and we can have different numbers of increments. I leave it as is and I click on OK. Here we have field output manager. In field output you can request the contours required for the result. So if we only want to have stress, we can get rid of them. We have different options here. We can have strain, stress, and contact forces. So if we uncheck this one and this one, we get rid of them. So we reduce down the volume of our model. And yeah, that is for the field output. We also have history output. We can create history output in every increment, and we can plot and post-process them easier. And as you see, as we are in step, we can also modify the sketch. So it's not just limited to part. And yeah, as you see here, we have the assembly. So from now on, we are not doing anything with the part here. The instances are here. So this is the part, and this is the instances that are assembled. So after assembly, we only deal with the assembled part, and everything comes after it. Okay, let's go to the interaction. So in this part, we can have different interactions, or we can have contact. We have different interaction properties here, like contact, film condition, or things related to fluid, stuff like that. Or here we can have interactions like surface to surface contact, model exchange, or if we have any crack to grow, we can use XFEM crack growth. So we don't need any interactions here. We can have some constraint, like having some surfaces to tie together. We can have rigid body, coupling. So let me introduce one simple interaction here. So from tools, we can create a reference point. So I want to create a reference point here. So reference point is a point that can be representative of one area or one region of a material. So I created a reference point here, and in the interactions I can have a coupling constraint. So it says select the constraint control points, which is this reference point. So I click on it, and we can have a node region. So for instance, this one, I click OK, and it inherits every degrees of freedom of this side, and click OK. So instead of selecting this edge, we can select this reference point to reference to this edge. So there's a pattern here. We have interaction, and here we have interaction manager. Here we have interaction property, and here we have interaction property manager. We have constraint here. We have constraint manager. So here, if we want to make any changes regarding this one, like for instance unchecking 1 degree of freedom here, we can modify it. We can rename it if we have different constraints, stuff like that. And here we have assembly, and on the features we have this reference point here, and here we have a step, and here are the interactions properties or constraints. So we have the constraint here to change. Okay, now there is a very important part of our study, which is the loads and boundary conditions. So for instance, here we can create a load, like I want to create a load on, for instance, pressure on this side. So I click on OK, and we can change the distribution. We keep it as uniform, and the magnitude is also in megapascal right now because we created everything in a millimetric. So if you take a look at the stress can be and should be megapascal. So 100 megapascal on this side, and click on OK. So as you see here, this is pressure. If we want to change it, we can go to the load manager, and from here we can double click and put the value of minus here, -100, it can be tension. Okay, there's also boundary condition manager. We can create some mechanical boundary conditions. We can create this in the step initial. For instance, if we click on incast here, we can select this region and assign a boundary condition to it. So incast, it means every degrees of freedom are closed and we constrained it from moving in this side and this side, and these are all free. So if we want to create another boundary condition, we can have displacement and rotation. So here, for instance, we select this one and we can say on U1, which is this one, it can move, or on U2 and U3 the movement is limited. So we just leave the U1 open, and as you see here, it means it's only constrained in U2 and UR3 direction, so only can move into the right hand side. Okay, these are the boundary conditions. It's just a very simple example. So this is a predefined field. You can use it for temperature, for instance, or we can have mechanical. We can have it like initial stress that the material is at, or in the welding, for instance, if you want to have a preheat, you can use other temperature and select the material and set the initial temperature. Okay, this is the load and boundary conditions. Now this is also one of the important things in the study, which is meshing. You can seed the part, like here you can say the approximate global size is 4. So if we hit apply, you see we have elements with the size of 4. If we reduced it down to somewhere around like 1, you would see the points would be closer together. So we just want to have something on, let's say 3, because in the learning edition the number of nodes are limited. So we have different mesh control here. We can have quad, we can have free medial axis. So let's have quad. We can have quad dominant, we can have triangular. If you take a look at them, I mesh it. These are triangular meshes, and if I change it to quad, we can have advanced front. It asks us to delete the mesh because we want to have a different mesh. So this is quad mesh, and if we have the algorithm of medial axis, the algorithm of meshing would be different. So just take a look at this, and here you see the meshing is different. And here we have assigned element type. We can have a standard or explicit. We talk about them later, but as you know, here we should have plane strain or plane stress, or if this is a thermal model, we should have heat transfer, but we don't need it right now. And sometimes we need to seed edges. For instance, if I want to have different numbers of elements on this side or this side as well, because it should be symmetry, so I hold shift and select this one, and done. We can put this on by number. We can say like we want to have 10 elements on this side, and you select this and you see the numbers of elements on them would be 10, and if we mesh it, we have 10 elements. Okay, left click on this and this and remove them. Here I can remove those constraints. Let's put this one on 2 and mesh it. This is a good mesh. It's better to go back to the load and boundary conditions because we want to submit a job. So I want to delete this one, and on this one we have U1, so we can have U1 on like maybe 1 millimeter here. So it means in the first step everything is in cast, but in the second step it displays only 1 millimeter. So we go here, we create a job, so we go to job and continue. Maybe it's better to rename the job name and say interface example, because I just wanted to show you different features we have here. We have general here, we have memory. We can set the memory to 100 if we're running something pretty huge. So we have parallelization, but in the Abaqus Learning Edition you're not able to change this. Okay, now we created the job and we want to submit this. The job is created and I think it is completed. Now as you see, the job is completed because we can monitor this. It was only a very simple job. It might not be very accurate. So if we take a look at the result, you see here, we can change it from here. So it displaces from here in 1 millimeter, and here we can have different contours. We have elastic, we have a strain, we can have maximum principal strain, or we can have stress. We have Mises stress, maximum in plane, or we have S11, S22 and S33. So we don't have any S33 here, so I put this on 1 Mises. So this is the rainbow contour. If we click on this, you see the animation. This is very fast, and since it's only one step, you can see here how it displaces. You can set and modify the animation. Here in the contour option, we have different options to, for instance, have, instead of having 13, we can have 22 colors, so the gradient would be smoother. If we click on default, we can have this one. We have color styles, we can have limits, or we can here click on show location for the maximum. For instance, it says the maximum stress is right here in this node. So there are other options here. We can allow multiple plot state, so we can have this one as well as this one. As you see here, it is displayed, so the boundary conditions were not set correctly, because in the correct example it should not displace from here. It should only like gets elongated to here, but we don't worry about that because this is only a simple example and has educational purposes. One another thing is to plot, so we can even plot them, create XY data, and from ODB field output, because we never set any history output, we only set ODB field output, we can have something here, for instance unique nodal, and let's say 1 Mises stress and like maximum principal strain. In here we can select some nodes, like maybe this node, and plot. We can have a plot of stress and strain. If we go here, we can even combine them. So if we create on this one, operate on XY data and continue, we can also combine them. So if we say combine and we have strain and stress, and we can plot them. So in this case we have stress versus strain, and you can see the plot here. Again, here in the results module and visualization, we don't have the model tree, but here we have different options like XY data. This is the plot. If we right click and edit, you can see the plot. You can copy and paste it in an Excel file. You can have different variables for X and Y, and yep. So let's go back here, and that's it. Now that you've learned the basics of Abaqus and explore all its modules, you're ready to build your first example. Click on the video on screen and let's start your first Abaqus lesson together. See you there.